No, thank you for coming along. I'm very excited that you've chosen my session, but there are some fantastic other sessions out there. So very, very thankful that we're all here today. But let's get started. We're going to talk all about that MLOps journey. We're going to be talking a lot about it. So before that, let's talk a bit about me before. So just a little bit. My name's Akanksha. Thank you for joining in. I'm a data and AI consultant. I'm based out of Melbourne. I've been doing that for like 5 or 6 years now. It went on longer than I thought it would, to be honest. But I do a bunch of stuff around the community. So if you're ever around Melbourne, please reach out. Definitely would love a chat. And I'm also a Microsoft AI MVP, so in and around that kind of ecosystem of the world. That's a bit about me, just to get a better idea of who I'm talking to. Have we got any software engineers in the room? Yep, fair. Any data engineers? Nope. Any developers who feel like they kind of fit into both but don't really know which one they fit into? There we go, better. Data scientists? Oh, okay, cool. We're going to chat after. I like this. This is a great start. No, it just gives me a better idea. Anyone who has an organization that is doing MLOps pretty well at the moment or is doing it at all? Yeah, okay, cool. And this is exactly why this talk exists. I like it. So let's get started. Like, why MLOps in the first place, right? In the last couple of years, especially in the consulting space, we keep getting clients that come in and they're like, hey, we built a model. And I'm like, great, I'm so excited. Tell me more. And they're like, we don't know what else to do. Like, we did it. Where do we go now? And that is a consistent theme. It's now become easier and easier and easier to build models, especially in the last 3 to 6 months, where everyone's like, oh yeah, that thing, it just does itself. We don't have to do anything else. It's going to replace all the people. So that's become a really good theme of like, yep, we've done something, don't know where else to go with it. What else do we do? So that became that conversation. I was like, yes, so you built a model. Tell me more. Where are we going to go from here? And it's really interesting how many people kind of forget the back end of what it takes to even get to this place in the first place. So we're going to talk a bit about that. We're going to set the scene, mostly because there isn't a lot of data people here, especially if you're outside that data space. These things and the fundamentals of how we get to a stage of a model being ready and where do we go from there do get lost in the translation. And they are really important when looking at the considerations of what else do we need to be thinking about as we move forward. So you got there by identifying a problem. Honestly, if a business comes to me and they're like, hey, we know we have a problem and we know this is the solution, which is going to have some kind of AI, that is miles ahead of what most places are doing in the first place. So you found a problem, you're like, right, this might be the solution. You found data that kind of answers it. You've got that collected. You started cleaning it up. You stored it in the right place where you can actually read it. And then what did you do? You've got all the data in one place. You're like, right, now I can start testing. Now I've got some data and I can start iterating on it. You build a model and you're like, it's kind of terrible. Like your first time around, then you start iterating on that to make it even better. It's a very, very long pro cycle to get to a stage of we've got a model. And that's where it kind of ends. Because what usually happens is your workspace. If you're an amazing human being, it looks like this in a digital formation of that. But it's very neat. You've got all these files that are well labeled. All your variables are perfectly clean and like, yep, this is what this means. And everything makes sense. But if you're more like most other people I know and myself, it looks something like that. Because a maths degree has corrupted me and I apparently can't label anything outside of XYZs and untitled file number 18, which isn't great when you kind of try and move on from I think that's the final model that says final model 3. That's not a great place to be to begin with. And that usually happens because there is a lonely little data scientist sitting in the corner somewhere, kind of forgotten about, because they really fought for that problem they wanted to solve. They're like, hey, I have a problem. I really want to solve this. And the business was like, go in a corner, tell us if it works. We will maybe have a talk about whether or not we put money into this. Because at the end of the day, when you talk about machine learning and try and get budget into it, it's a really hard sell of, hey, give us some money, we'll find a solution. But we can't guarantee what the solution will be. It might be terrible. It might just be, we can't do this. That's a really hard sell. So they usually get left alone, and that's where they end up sitting in kind of tiny little rooms. So where do we go next for these poor data scientists? They sit in a tiny little room where everything's up in flames because they've tried everything. Everything's just kind of there. And they kind of tend to say, well, it worked on my data and it worked on my machine. I'm done, and this is all I have to do and worry about, which isn't wrong, right? Like, you can't fault them for that. They've done their job. They've built a model, they've got it working, and they've got it working to a pretty good level with what they had. Where to go next from here, That's not their problem anymore, seemingly. But you do need a lot of people to kind of pull together into the sphere to actually get it to go anywhere. So let's talk about that. Where can we go from here? Because what tends to happen when clients come to me is I'm a little bit too afraid to know what happens next because we think we did the thing. Because everyone talks about, hey, have you got AI in your business? That seems to be the biggest conversation. It was like, have you got the buzzy word now? Last year it was something else. This time around it's all the LLMs. Have you done the new thing? Which isn't a great solution to begin with or start with at the end of the day. So that's where MLOps comes in. It was a very, very long introduction to get to where we did, but that basic understanding of all the kind of real hard work that goes into getting to that just very fundamental stage is needed. What is it? It's a very fancy way of just saying, hey, how do we operationalize machine learning? Which sounds very fancy, but it really isn't. It's just, hey, how do we automate all this that we've talked about in this whole process so that humans who break things all the time can't get into it and break it all the time? How can we make it a bit more reliable? So the main kind of aspects that we look for in kind of adding MLOps into any process, it needs to be fast. We don't want everything to be fast, but especially in this world where we're, hey, this is something that's meant to make our lives better and smoother. We want it to give us results faster and we don't want it to be wrong. So we need it to be reliable. That, hey, at any given time when I ask you questions, I want you to be correct. You've built the model today, amazing, but a year from now, I still want it to be accurate to whatever else has happened. Another 2 years from now, we might have another pandemic and the data completely changes and the whole trends of everything change. We want it to be able to scale to that and understand that limit. And now we're talking about added data over 2 years. So we also want a little bit of scalability because there's more and more data coming in. We need that to be stored in a way that's actually accessible and manageable over time. And also the fact that it's growing, therefore resources need to grow and we need to manage those resources. So kind of all of those main things encompass what MLOps is all about. Those are the big things that we want to be aiming for. So with that, is it just DevOps? Kind of. It's not far off from it. It is essentially the same thing, but it's just dealing with a very different foundational underlying basis. I'm sure people have seen this diagram. It's a little bit blurry, but yes-ish for all the software devs of like the iterative process of like, hey, we did a thing, we deployed it, and we found a bug, so we did another thing, and we just keep going in circles. It's kind of the same thing. This is what MLOps is at the end of the day too, just making that whole process quite smooth, where the external things just happen on their own and we're just working on small iterative bits within the whole process. So the only thing that changes is just the underlying thing, which is the ML process, the end-to-end ML process, this big giant thing that we've touched on, but what does it actually kind of look like in depth a little bit more? There's the data dev part, where we've got the data, we're storing it, we're making sure it's correct, we're making sure there's no changes randomly happening, no schema changes are going down the line, there's no data types changing along the way, nothing's breaking our systems out of nowhere because that happens so consistently, it is a nightmare. Model development, this is where the actual model builds happen, right? So we're trying and training and testing and more data comes in, we're updating the models, we're making sure everything is reflective of the truth as much as possible and accurately. Production deployment, this is where the bit that we've been talking about this whole time, right? Like, hey, how do we get to deploy this in the world? What do we need to do to get there? There needs to be something to make sure that happens. And once it's out in the world, hey, what's the business use, right? We had a problem that we started with at the start. There was a reason we did this. How is that actually going? Can we monitor the use? Is it answering the question that we started to use the whole process of this with? So with that comes team members, and this is where all the considerations start, essentially. Have you got the right team around you to do this? A single lowly data scientist sitting in the corner of the world is not going to be enough, mostly just because they can't have all the skills in the world that you need to be able to do this kind of work anymore. Usually a team for work like this in general would have your data engineer. They would also have your data scientist, and they'd also have an ML engineer. These roles are very similar, and people do confuse them a lot, right? I'm very much of the philosophy of like, call yourself whatever you want, you give yourself titles, you work in whatever you want to. But that also kind of leads into the, wait, what are your responsibilities now? Because you have randomly just changed your role title. Do you understand what comes with that? So within that process, they kind of slot in fairly evenly, right? The data engineer is going to be working on making sure all the data stuff, the storage, the quality, all of that stuff is going well, and it's going from one place to another, and it's all moving perfectly, and nothing's just breaking out of nowhere. The data scientist, once he's got the data, they're like, right, this is it. This is my time to shine. I'm going to build my little model and I'm going to just wow everybody, which is great. I want that to happen. Then they kind of do the whole thing of like, well, it worked for me and it worked on my model in my machine. That's my job done, because that is where the ML engineer kicks in, and they go about the process of building that infrastructure and tooling to make sure it actually goes to deployment. Understanding these different roles and responsibilities, while it sounds very, very basic when you hear it like this, is a real lack in the system at the moment in Australia, where people are like, yeah, we've got a data team. And when you go talk to the data team, they're not sure what their responsibilities are. And also there's skill gaps. Those will exist forever. I mean, there is a real skills shortage that is currently happening in Australia. This is a problematic area where things go wrong because they want to do this. Businesses are ready and wanting to do this, but there is just no people at the right levels within that business able to do the work. So once we've got an actual team with us and making sure that they are actually able to do it within the environment you've set up, there's a few other considerations that come in. Right, okay, it's like, right, we've got a model, we've got our data, we've got the people, and now there's still so much work left to do. So let's go through a little bit of it. So the team structure. If you are a fairly small team where there is one of each, or maybe one or two of each, and there's multiple different data teams, 4 or 5 people, that's fine. How are you going to set that up? Have you got one project coming in? Have you got multiple projects coming in? Have you just got a workspace in whatever cloud provider you're using that every single person on that team has access to? Like, off you go, do whatever you want. Or is it going to be, okay, we're going to have multiple projects, let's separate that all out. There'll be a workspace per project. And then there's the really, really rogue ones that do just a free-for-all. It's like, here's a space, enjoy. Would not recommend unless it's a single solo team. It's usually for a research/experimentation, kind of a POC level, if you're trying to do that. Within that workspace, I mean, you might have scenarios where you've got multiple people working on different projects and they kind of jump in and out of different things. Or there's just the fact that, hey, we've got very dedicated teams working on dedicated projects. Make sure people are aware of who has access to what. Those things go wrong so quickly in terms of, hey, who is building things? Who's spinning up new resources? Who has access to the raw data? And I don't mean like the real raw, like in the bronze level data centers and stuff like that. But I mean the ones that are sitting there ready to be used, having cleaned up everything. And they're like, yes, this is our clean data. Make sure that's locked down. People can get in there, people can mess things up, and they don't mean to. Nothing is done on purpose, but things go wrong very quickly. So making sure that is defined to the nth level as much as you can beforehand, and understanding their team, right? This goes back to, hey, what is your team made up of? What is going to be the process around this? Because how are we going to set this up? Workspaces are easy to create, but they're not as easy to manage. So once you've built them up and you've got all these resources floating around in them, it's going to be really, really hard to break that apart and put things into different places, especially if you've got loads of data and everything's already been built. Breaking that out afterwards is a big pain. So as much as you can, considering that before you get started, you would be shocked how far that will go. Environments themselves. So we've heard of dev, test, and prod environments. It's up to you. Pick whatever one you want, right? I am a consultant. It depends. It's going to be a big variety of this conversation. But even within that, if you are a business and you are a team that is fairly limited on what your resourcing and capacity is, maybe this works for you, right? Where you've got everything in development in that kind of sandbox environment. You're like, yep, we've got it locked down. This is our final model. That's what goes to test. Everything works. We can fix any bugs in the dev environment, and then the final one goes out to the prod. It's the least resource-heavy solution you'll probably have, just in the sense of there's not as much to manage, but it gets messy very quickly. It gets really at a level of like, wait, we've tried one experiment. Where's the next one? Where's the next one? What's our final looking like? That does happen. So do we want to then maybe split that out into each individual environment having all sets of resources? There are businesses that do this. There are businesses that do it somewhat well. I won't say they do it really well, just because there's a lot of resourcing involved. There's a lot of management of that resourcing. And people kind of do forget about this, especially because when things like this are being planned, quite often infrastructure is not always in the room having that conversation with them. It's usually just a data engineer or the ML engineer being like, hey, we need this, this, and this. We need this many servers. We need this much compute power. Let's go. That's usually what happens, which there's nothing wrong with that until everything kind of goes up in scale, and then they get the bill at the end of the month, and then everything goes up in flames. So that works, but doesn't quite often scale as easily as you think, because the minute you start adding things, that is triple the amount of resources you're trying to manage. So a good midway consideration to make is having kind of a dev and a prod environment where maybe in the dev, you only have access to a sample set of data. You don't have access to basically everything, but a good selection of the sample data. That's where you build and test everything out in, and then move along to the prod where you're then able to push through things. Again, this will depend on your solution. None of these are going to be a fit for every single business because shockingly, it'll depend on the context of what your data is and what it actually looks like. Those kind of three environments, depending on those, you can mix and match within them. You can mix and match, figure out exactly how much sample data and things you want within your dev environment. You play around with it, but make sure you sit down and actually talk through with your team beforehand in terms of estimating how much things are going to go through there and how much resourcing you're going to need before. So those are the three different environments. And I feel like I'm talking at you for a good little bit, but a lot of this is going to sound very, very basic. And I know that, and it really irritates me that it sounds so basic. But these are the things that are consistently going wrong in businesses or just missing. It's not even the fact that they don't forget to do this. It just falls through the cracks quite often. People are just so used to doing very routine amounts of work. Like, yeah, well, I need to do some work, so I'm going to spin up a compute power, which I can use with some Python and create a model. They don't consider the back end of what else can go wrong with that. So within that, regions is another set of consideration to make sure you're thinking about. Where is your data being stored? While you're training your data, if low latency is a requirement for you, where you need to be very, very close to your actual data set, make sure it's in that region. But also then comes the conversation of sovereignty and regulations and governance. Are you making sure that your data is not leaving the shores it's not meant to? If you're working for certain clients or for companies, you might have regulations of, hey, it can't leave Australian shores. That's fine. Put it in a data center here. That's where you can train. What are the implications of then actually using a model that's been trained on Australian data being used other places? Make sure you know exactly what your limitations of the data governance is within that and then store it accordingly. Serving of the model itself. It is usually preferred to be serving the model wherever your customer is going to be using it. So if you're working at a more of a global scale and you're building and training your models here, but your customer for certain products is going to be in America or the US, you can serve that model up as a production level in that place. It does make it easier for monitoring and purposes. The other end of it is fine-tuning. What I mean by that is kind of, especially if you're using pre-built models, which more and more people are now, which I'm kind of glad for, to be honest. We don't need to recreate the wheel every single time. If there's a pre-built model that fits your need, off you go, use it. It's great. It still fits into the same kind of theme. It still fits all the same considerations, maybe just a little bit less of the data sciencey bits. But when you're fine-tuning them, right? So these LLM models, they just know everything and anything, and you can kind of tune them into being your perfect model and kind of exactly for your solution. Where are you doing that fine-tuning? It might make sense to actually break that out. You've got data stored across all over the globe. It doesn't make sense to basically recollect it and purpose it into another location and then add on any more fine-tuning on top of it and then separate that back out as different models. You can do that in local areas and stuff instead of kind of constantly moving your data back and forth. There's a lot of things to think about within this. There's also things like pre-built models or any added enrichments. If you're using cloud providers, they have limitations on where those things are available in terms of your regions. So if you're going to be looking at leveraging those things, make sure your data is actually available in those regions because they do limit those quite severely at some stage. Like especially if you're looking for like really new rollout stuff, those get rolled out to like 4 or 5 data centers to begin with globally, but very limited data centers that have access to them in the first place. So if that's something you're going to always need to do, make sure your data is being stored in one of those data centers so that you have access to those features when you need them. Right, okay, so we've considered the actual team we've got, how we've set up the team. We all understand, we're all talking to each other for once that, hey, this is what I'm doing, and this is where I need help basically setting up the other bits. We've worked all that out. We know where the environments are. We know where everything is sitting, how we're going to talk to each other, how the resources are going to talk to each other. The other thing I want to talk about here is resourcing. And what I mean by that is mostly machines, not actual humans. We've kind of talked about between roles and stuff. But the machines themselves, spend the time as much as you can to actually estimate how much you need. And this is a consistent complaint I hear from like infrastructure people of those ML engineers, those data scientists, they just spin things up willy-nilly wherever they want, and then they just leave them to die. And they don't even use half the stuff they bring up. They don't even know how much they actually need. They just cost us money and security because they've just spinned up all these things and no one knows who has access to what. That does happen. If you can spend the time to just estimate even just the smallest bit, you're not going to be 100% correct. It is estimation, but even just a little bit, to just take your time to be like, right, what are we actually going to need and why are we using it? Take the time to write those considerations down. Why did you decide that at the point in time? Make sure it's all documented so you can refer back to it. People move around a lot. We don't live in a world anymore where people are going to stay in the same job and will know every single thing about that job. Those documentation things are very, very important. So when you make those decisions about resourcing, make sure it's written down. And it's not just because of costing. It's also the fact that these are actual computing machines. They do require energy and they do require effort. And we are living in a world where there's global warming and we should be cutting down on our consumption. I would be the first one. I'm guilty of saying, oh, just spin up a server somewhere, it's fine. I don't need to have it on my laptop because it's fine. Somewhere else has it. It's so cheap. It's so easy. But there is a genuine impact on what you are using and how far it'll go. So yeah, within that then the pricing comes into it. And that pricing is also just the fact that, hey, if you're spinning up more and more resources, you need more and more support, making sure those resources are okay and they're not breaking and there's monitoring involved. So that pricing part goes hand in hand with not just, hey, we're paying this much for this cloud provider that we've borrowed stuff from, but also the fact that you're actually having to hire more and more people to make sure that doesn't just go up in flames. So estimation, just sit down and do a bit of estimation. There's a lot of that still missing in the world at the moment. Pipelines. So we've now talked about kind of where everything is getting set up. We talked a little bit, so this was all like, how do we get to it? How do we make sure it's fast and all there and reliable? And the biggest part about that reliability was we're all humans and humans like to touch things and they break things. So how do we take that piece away a little bit, kind of automating it with using some pipelines? So the main three parts that we've talked about quite consistently, I think, at this stage of the ML process has been the data dev, the model dev, and then the actual deployment of the model itself. So there can be different pipelines that go hand in hand with each of these processes. The data pipeline, which will obviously sit into the data bit, the environment pipeline, which can be really, really helpful in actually spinning up the environment that you need when you need it, and then spinning it back down when you're done using it. So you're not leaving any resources available and just waiting to be used and costing you money. The model training pipeline, that just kicks off a job, updates all the models that it needs to, and it spins back down. And then the actual deployment one pipeline after that. Let's actually go through them just to know a little bit better about what's actually happening and what you can and can't do within them. So when it comes to the data pipeline, yep, obviously it'll create the data sets, it'll find them. You can put in as many different variations and stuff within that of like, hey, these are the data transformations I want. This is exactly what I want my data set to look like. Put it into the right data storage, make it available to the actual services that are going to ask for its data from there. And then register that as a data store. Once you register it as a data store, in most places, that's like your final registered data set you can kind of talk to at the end. Environment pipeline, there is going to be a lot of softwares and different packages and different libraries you use in terms of most of this work, especially if you're building your own model, or even if you're not, if you're using a pre-built model, there's going to be different variations and versions of them that exist. Your solution obviously works on a very specific outcome of it. Make sure that's been documented and that is the one you're constantly reverting back to when you're building this. Otherwise, everything will break and you won't know which bit has broken it. It's a very safe way of constantly spinning up new cycles and environments. And then, so the model training pipeline, basically, this can be just used from the Hadoop pipelines where you pull the data set that you've created in your data pipeline. You have a functioning ML environment that is suitable for your requirements that you've decided on. And from that, you can retrain that model with any new data that's come through, get that model updated, it now understands the latest updates, and then register it as the final model. You can also add in whole different loads of parameters into this of, hey, is this now meeting the same level of accuracy as the previous model? Is it actually meeting kind of like this is the reactions I want? Is it missing up any, like all your unit like testing and stuff? Put that in there. It won't register and update the model unless it's actually sure that it is the better version of the model. And it should at least meet kind of just about the same criteria. If it's really, really off, have some alerts in there of like, hey, something's gone wrong with the latest data set that we have because our model's gone way off the bat where we were. So all of those kind of things can fit into your pipeline. Just depends on exactly what you're trying to do with it. The model deployment pipeline is very similar to the previous one, but we're just getting our model instead in the same environment, packaging it all up and hitting deploy. Again, this is kind of doing the whole thing of let's not break things when we don't have to. All of this can be automated. It also takes out a lot of the work in terms of just pushing buttons and manualization of labor, whereas those people can then monitor and actually work on other projects instead of being stuck constantly hitting the word deploy. So we've got a few pipelines that have fitted into this whole world of MLOps and the journey. There's been a lot of kind of like, have you thought about this? Have you thought also about this thing? But adding more of, have you thought about this thing? Triggers. What's triggering your pipeline? Really have a kind of, this goes back into it depends, and it depends on your context, but what is your data? How often are you getting new data that is actually valuable to the end user of your model? You might be getting new data every hour, but a person actually using your model might not need to see the updated model on an hourly basis. They're okay with like a week-old forecast. It won't make an impact. What is the actual severity of your updated data, implementing and all that different processes? That's going to be a big part of your triggers. Your data pipeline, that probably needs to run every single day. If you've got a whole load of data, maybe it needs to be running every hour. Depends on A, how many people you have to monitor that run. Of like, hey, it's kind of breaking every hour and it's actually not doing anything and everything's falling behind. That's not great. If you've got only capacity to manage that on a daily basis, put it down to that. Even less than that, make the most of what you have around the people you have. The other thing of the model training, so the data is getting updated, let's say, on a daily basis. The model itself does not need to be trained on a daily basis. The model can be updated maybe once a week. If you really don't have like very pressing important data, it can be trained once a month. Really have a think about how often you actually need for that to be updated, because again, all of this stuff actually takes resources. It takes machines running this thing, and that costs a lot of money, and that costs a lot of resources in the world to be able to do that. So just have a think about that, and then think about what is actually kicking off the next thing. Make sure things like your model training pipeline running before your environment is set up doesn't happen. That has actually, I've seen that happen many times at businesses. You'd be surprised. You're like, oh, of course the model isn't going to start training when there's no environment in it. It does, and then they all constantly just see failures happening. Like, well, this is not a process that works. So that isn't a great outcome, but it's just very small things that keep kind of tripping people up in businesses where a lot of this just gets a bad rap, but it's just very small things that can be fixed. Rollbacks is a big thing with having MLOps. Essentially, you have pushed data through. It's been trained. It was faulty data. You realize because at the end of the day, the person who's using the model is telling you, it's getting me really, really wrong results. That's not a great outcome, especially given the context of it took a lot of faith and power to get this machine learning model off the ground. You lose a lot of trust and credibility the one time it goes wrong. So you don't really want that happening. And when it does, you're like, no, we've got to fix straight away. Don't worry about it. Let's just roll back to the previous working model that we had. It's better than having to go through and be like, right, okay, how do we fix this specific problem? And how do we find the last model? Which one worked last? What was it called again? Was it final model 4? I don't know anymore. That happens quite often as well. But the rollback options does provide a little bit of safety, especially for that trust kind of worry that tends to go around quite often. But with that, there's just a few extras I want to talk about in terms of other considerations you might want to make in this whole process. Naming conventions. We talked a lot about having different environments. You might have a dev, prod, and test. Naming conventions across the board in all of those are very important. You'd be surprised how easy it is to have a data set that is a dev data test getting pulled into the prod environment and actually have training done on top of it. And then everything else just starts misaligning and you've no idea where it's gone wrong. All of the way through from just not even just environments, but variables, individual variables. There's a lot of featureization that happens within models if you've gone into that aspect of it, which I think we only had one person say they were in the data science side of it. Featureization and stuff, all those variables get named bizarre things. Like there's fake dummy variables that get created in the data set. We want to make sure those actually mean something at the end of the day when they push through, and you don't have random things like dummy variable 5 being the one that's being shown to a customer. Code quality checks, make sure that's a regular thing that's happening. It's actually really, really hard to make sure that happens. But we talked a lot about kind of the custom packages and all the different environments and all these new models that keep coming up. There's updates to those happening, I'm sure, like every day at this stage. There's probably a new software package that's dropped. There's a new version of something coming along. What is your requirement? Do you need to be moving up? Is there a better feature? Will that give you a better accuracy? When do you actually move up? What makes more sense? Will that change break everything else? Maybe. So planning to do the code quality checks will actually improve your business in general. Tracking how and when you're doing them, always very, very good. But also just the fact that it won't break stuff because you've been making tracks of it as you go goes a really long way. Frameworks. Build out frameworks for how you are planning on doing these things within your business and make sure those are written down somewhere. So a consistent thing is like, oh, build a pipeline. Go do that. That's great. I've got multiple different data engineer friends who are like, yes, it's so good when people can just go build their own pipelines. I'm like, amazing. It takes a load off your work, right? And they're like, yep. Until they come back and they're like, everything's messed up and I have no idea what's gone wrong. And you start to try and help, but they have no idea what they've done because there's no kind of set procedure across the business of how they're going to go about doing this. And this tends to happen quite a lot, slightly bit like larger, more mature environments where they're like, oh yeah, we're so consistently used to doing these things. That's fine. Following frameworks and setting up frameworks in the first place, they take a lot of manual effort, like upfront work, but they pay themselves off. Because if you're starting to build pipelines and everyone just makes their own, the support required for those grows at a very linear pace of, hey, we built another pipeline. That's literally another person having to make sure that works and there's someone backing it up whenever it fails. What should be happening is the fact that, yeah, growth, there will be a growth in terms of how much support is needed for as many resources as you create. It really should not be linear. It will grow, but it should be at a manageable scale. And this kind of goes back to the planning side of things. Do we have enough people to be able to support that level of requirements? Documentation. I feel like I've mentioned this many, many times by now, probably, but it really, really is important. The amount of times, I say amount of times, every single client project I've been on, I would say I have struggled with trying to figure out what is or isn't happening. And that's usually in the case of, okay, how do we figure out? I'm like, we usually always put in a week of discovery. That week is honestly just trying to find people to talk to. It's not even you should talk to these people. It's trying to figure out who has the information and then getting to a stage of, is it written down anywhere? Usually not. Okay, let's start writing this down. Okay, great. What else do we know? And that kind of stuff happens very often. And it is avoidable if we start just, even yourself, right? Like, okay, the rest of the business hasn't written anything down. The rest of the business doesn't have great documentation on certain things. If you just start writing your own decisions down, it goes a really, really long way. And it builds a culture of documentation. When it comes to MLOps and these things, these are very important because 2 years down the line, honestly at this rate, 6 months down the line, there will be a new product that's out there. There will be a new tooling service out there that someone's saying, hey, we should upgrade. There'll probably be somewhere in your own documentation a consideration as to why you didn't choose to do that in the first place. There will be reasonings as to why you made the decisions you did in the first place. The other likelihood is the people who made those decisions have long moved on. And those knowledge shares don't happen as often and it just disappears. So when you go down the path of like, right, okay, we're going to do this, we're going to update into this new world of new tooling or whatever it is, and it then breaks, this could have been something that's avoidable because that was already probably decided and figured out. Model validation across segments. This is something very specific, probably towards the data science side of things, but testing this out is really important, especially when you're deploying models out into the world. A model can work really, really well at a large scale, right? So for example, I don't know, we're looking at forecasting revenue for Australia. That might work really well. There's enough data across it, we can predict it pretty well. But if you start breaking that down into, hey, can we predict what the Melbourne office made as revenue? Okay, that was pretty good. Sydney, pretty great. Perth, not so great. That was actually really not great at all. Mostly just because there's not that much business that's going through Perth comparatively to Sydney and Melbourne in this made-up example world. But what happens with that is the fact that, okay, well, there's not enough data. If the business user is trying to do that and they're just seeing, okay, well, that's what I'm going to believe to be the truth, it goes back again to that trust building exercise of, hey, this is failing. All those things glowing up and kind of merging into one, joining up into a big overall model, that will work. But when you break it apart, it might not give you as accurate results. And And you need to be testing those out and maybe not surfacing up those solutions. So you might not let people have access to predicting revenue for Perth because it won't be as accurate because there just isn't enough data. Trying to actually go into those details and make sure what is being surfaced up as a model to your end user is really important. Like, what can and can't your model do and what is it good at? And making those assumptions very, very clear to the end user so they're not getting confused as to what's going on. It's the same concept with ChatGPT, where at the start, they're like, it can do everything. And of course it's telling me the truth. And then you get results and you're like, oh, it was obviously not telling me the truth. That was a very clear lie, where it told me my own name didn't exist. And I'm like, I think I do. I don't know why you're telling me I don't. But it says it so believingly that you do believe it. The same thing goes in terms of if you've built enough trust, people will believe it. And the minute that trust gets broken, it's very, very hard to come back from. And last but not least, resource utilization. Make sure you're consistently going back through and monitor, like that monitoring piece of what are we using, how often are we using it, how much are we using it. All of those questions are being recorded and kind of tested and analyzed very often, mostly again, because these things cost a lot of money. AI has become a very easy word for businesses to be like, yeah, we're going to put that in. It's going to save us money and it's going to be great. But to actually implement these things costs a lot of money and it is not an easy process. So when you're using these things, and again, to go back to, it's a really hard sell for most businesses. Like, I get it's changed a little bit in the sense of like, oh, AI, we want it. But it's still in actually deploying and getting the people and hiring people to do this work, it's a hard sell because you don't actually know what is or isn't going to happen at the end of the day. So you don't want to be wasting money and budget where you don't need to. So consistently going back through and kind of checking and making sure there's no gaps in those environments, yep, that'll definitely help out in the long run. Where do we do all this? This is an interesting one where whatever environment you choose, I am happy that you've chosen it because it is an environment that you understand. I don't ever want to kind of fall into the trap of like, it must be this. It must be this tooling service. It must be this requirement or this cloud provider. There is no right answer to this solution. The right answer is whatever the people you have, the role players and the data engineers and the data, whatever they are comfortable using is the right solution to use. And I say that consistently because there's a lot of kind of fear mongering out there of like, oh, if you don't have this tooling, it's just not going to work. If you don't have this, it's just not going to be a sustainable solution. And it's not really true. The best solution for your business is going to be one that you can maintain. And this happens quite often where we'll get, it's like, oh, we have this thing that works, but we want to migrate everything up onto this other cloud provider. And the question is usually why? And they're like, oh, but that's the one that works. And that's never really going to sustain itself because the people don't know how to do that. And the people then don't know how to implement it. And then cracks start happening where all the things that we started to try and build, they all start falling through the gap. So where do you do all this? That's up to you. Come talk to me afterwards about where people are and aren't doing this already. I'd love to have a conversation about it. But I won't dive into a lot of like hows to do this because that's going to be another 3-hour session in and of itself, realistically, of how do we go about breaking down all these different things and where do you create pipelines and all the things. I'm happy to share resources around exactly where those things exist in the world, but whatever is the best fit for you is going to be the most optimal solution, I can guarantee. So as a recap, I feel like that was very talk heavy, just me talking at people, but let's slow it down a bit. So what are we doing? We just want to make things a little bit easier. And that's usually future-proofing things for ourselves, where our future decisions are a little bit easier. We know exactly why we did the things we did, and we're just preventing ourselves from breaking things a little bit. We do it just mostly because we don't want to be sitting in a burning room with all of our hard work kind of wasted away in a corner of a space. I'm haunted by the ghosts of my POCs that have just died in a quite lonely death. But we all do this because we want to have a problem to solve. There was a problem, which is why you started building a solution. We don't want it to disappear and just sit in a corner. We want to make sure it's actually seeing the use and the business people and whoever is at the other end of your customer actually making the most of it. When to do it? Honestly, usually whenever you get the money to do it, whenever you can convince the people to actually commit to actual budgets against these projects, go. Just get onto it, get started. obviously take your time, do the considerations, don't dive into just building. But when is usually associated to the budgeting process of it, how quickly can you do it, is where money is associated. You'll get the money usually when you've proven a value to it. So you're usually at a stage of, hey, we've got some data, we've got somewhat of a POC where we've tested it, there is a model that will work against this, there is some use to it. That's where you'll probably get approved for budget and therefore are ready to go. The where, like we just discussed, wherever you wish. Honestly, it can be on Azure DevOps, it can be on any other DevOps related website, any toolings that you're already using. Feel free to go forth and use whatever you might. The how, again, this falls into that will be a 3-hour conversation. If that is something of interest, maybe we'll build out another talk around that whole area of how do we actually build all these pipelines and different environments with the best ways of doing it in the future. But with that, I think that's everything I kind of had to talk about in terms of things you should probably consider before you do this in the future. Thank you for listening. I know it was a very talk-heavy session. There wasn't a lot of demos, which are usually nice in terms of breaking things up. But this was just me and my opinions over the last 2 years, kind of, that I'd rambled on about. And I was like, it'd been simmering away in the back of my head. That I was like, right, might as well go tell other people about them, that this is what's been happening in my experience of MLOps. But that's everything else from me. I'm more than happy to hear about other people's experiences or if there's anything else that can help clarify. And I will be around kind of today, tomorrow. So if there's any other time you want to hunt me down and ask anything else, I'll be there. But yeah, other than that, thank you. Great, no questions. Amazing, I've done such a good job. This is perfect.
There's a lot of questions, but it's like different opinions.
Oh, then we'll have a chat, Tim. This is great.
Are there any frameworks out there which describe all of these?
Yeah, there's definitely, I mean, there'll be frameworks for individual bits of it. There's a GitHub resource called Amazing MLOps, I want to say. I'll try and find the link to it. They've got like genuinely like hundreds of different like other talks that have been done about this content, other framework, like everything pulled into one place, essentially. It's a great resource for it. But yeah, in terms of frameworks, it'll probably be just broken down into like individual aspects of it, which isn't helpful because it's not one overall one, I know, but.
I guess I've been on that window.
Oh, yeah. Yeah. There's like Dr. Larissa V, I can never remember her second name, but from Europe. She's great, kind of pulls a lot of that kind of content together. Cool, well, thank you, folks. I mean, I will give you back a little bit of your time.